Hi, I'm Miriel. I'm in my final year of my Bachelor's of Landscape Architecture at the University of Oregon. Today I'm going to talk about my 2024 SURF project, which is a survey of understory species in Amazon Creek and Eugene. This project was supported by the Center for Undergraduate Research at the U of L. So I collected a lot of data for this project, and I'm still in the process of analyzing it and putting together a comprehensive report. So this presentation is going to be more of an overview or a preview. First, I'll give some context on the creek and its surroundings, then identify my site specifically. I'll touch on my methods for data collection and the limitations of the project. I'll identify the segments that I split the creek into, and then get into some results for the creek as a whole and for individual segments. I'll close with a quick look at some of the photos that I took over the summer. So first, some context. Amazon Creek is a tributary of the Long Tom River, which in turn is a tributary of the Willamette River, which runs through the Willamette Valley. The creek originates in South Eugene and feeds the Long Tom as well as Fern Ridge Reservoir. Much of it runs through private agricultural property, but I'm going to be focusing on the section that runs through the city of Eugene. So the site I looked at specifically runs from the headwaters in South Eugene near Frank Kinney Park to Royal Avenue at the edge of the city boundary. This project was meant to be kind of a wide-reaching overview of the entire urban section of the creek. So in the early days of Eugene, Amazon Creek used to regularly flood, which was viewed as a nuisance when they were trying to build a city and maintain a city. So in the 1950s, the Army Corps of Engineers channelized the creek and built the concrete walls that still exist in some sections today. Since then, the creek has undergone various restoration projects by the city, but some sections are doing better than others. The survey period took place between June and October 2024 and was self-led. Survey days consisted of equipping my hip waders and walking through the creek, taking photos and setting ID points on my phone with GIS software. Identifications were made in the field and then reviewed after the survey period to maximize accuracy. My background is not in botany, but as a landscape architecture student, I do have some schooling in plant identification. So I used a combination of my prior knowledge and reasoning, as well as online identification software such as iNaturalist and PlantNet. So some limitations of this project: no trees. The City of Eugene Urban Forestry Department has an excellent interactive map of nearly all the street and park trees in town. I decided specifically to work with understory species to supplement that mapping and celebrate some of the more ephemeral riparian species that we see in the Willamette Valley. I also ended up having to cut out grasses as a category due to just their density on the creek and omnipresence. Grasses on the Amazon Creek could easily be their own survey in themselves, which I hope someone conducts someday. And then finally, willows are another big player for almost the entire creek, especially the segments in West Eugene. They are planted very densely by the city, and there are a variety of species. It was not within the scope of this project to identify the individual species because there were so many, or whether they are entirely native. I don't know if they use an entirely native planting palette. So for this project, all of the willows are marked as Salix species and are not identified as native or exotic. When analyzing the data I collected, it was helpful to split the creek into segments defined by their neighborhood context and the level of disturbance. The first segment, beginning at the headwaters in South Eugene, has a high native population and is the least disturbed segment. The second segment mirrors a running trail and has a relatively high native population with relatively low disturbance. The willows start to come in here as well. The third segment runs through Amazon Park. There's more disturbance here from parkgoers, and we start to see a stronger exotic and invasive population versus the natives. The fourth segment is the only one still channelized in concrete and has very low vegetation. The fifth segment runs through the fairgrounds and residential neighborhoods and is dominated by willows with moderate to high disturbance. The sixth segment is similar, but almost entirely commercial and industrial. Getting out to the last segment, this one runs through a nature preserve, and there has been a concentrated recent effort to restore this area, so we see native populations stronger here as well. During my survey period, there was active construction from 24th Avenue to 19th Avenue, as the city is conducting the first of 2 phases of dechannelizing and naturalizing this section of the creek, which is very exciting. But as a result, I was not able to collect data points on this segment. Here's a very broad look at the results that I got. So I collected 1,585 unique ID points, and each point had 11 data features attached to it. So those features were genus, species, common name, the origin, so was it native, exotic, or was I unsure? The prevalence of that species in the point that I was collecting, so was it just present, was it competitive, or visibly dominant? The location, was it in the water, on a naturalized bank, or just near the creek? And then each point also had some information just about the area that I was in. So was the area channelized in concrete? And then was the relative vegetative density high, medium, or low? And then each of these points also came with a photo and were automatically tagged with date and time and their GPS location. So this is, again, a very broad look, but you can see here how much variation there is in native versus exotic plant populations depending on the area of the creek. The segment closest to the headwaters has the highest concentration of natives, as well as the segment near Royal Avenue where there has been more restoration effort and less human impact. Overall, my survey returned 41% native species and 52% exotics, including invasives such as Himalayan blackberry and English ivy. It's important to note that this only shows the presence of these species, not their prevalence in a given area. Generally, invasive species are more likely to take up more space and be marked as dominant than the natives. Here's a quick look at the relationship between concrete channelization and overall vegetative density. You can see a pretty strong relationship here. Nearly all of the naturalized segments had a high vegetative density throughout, regardless of their species makeup. In the concrete channel, however, it is hard for anything to grow, even aggressive species. And this is just a side-by-side to show that difference. So these are 10-foot concrete walls, no soil. It's hard to be a plant in that environment. So getting into looking at these segments individually, I'm going to do just a brief look at the native populations for each one. So starting from the headwaters, again, we can see that the first segment has the best native versus exotic ratio of any of them. The natives are actually winning out over the other species. Past Snell along the running path to 30th, we still see a roughly 50-50 with the natives actually still winning out just slightly. Moving into Amazon Park, there's more human interaction with the creek here, and we see a shift to exotics winning out over natives. We also see willow start to be a really big presence. 19th to Jefferson is the concrete segment, so almost entirely really tough species, most of which tend to be invasives. A lot of this was blackberry. Jefferson to Garfield is the fairgrounds and residential and commercial areas. There's a lot of human interaction with the creek here, including camping and unfortunately a lot of trash buildup. Same goes for the next section out to Deneba, which turns into a more commercial and industrial area. And we can see that the exotic species and invasives start to take over more in these highly disturbed conditions. This final section from Deneba to Royal runs through a nature preserve, as I said before, and there's a sharp decline in camping and trash buildup. There are stronger native populations out here due to restoration efforts and low disturbance, especially towards the end here, which you can actually kind of see on the map. This is also where the creek splits in two, so half of it is going into a channel that drains directly to Fern Ridge Reservoir, and then half of it is continuing on into that private agricultural land and eventually meets up with the Long Tom River. So finally, here's a quick look at the 10 most frequently occurring species across the whole creek. Of these, the snowberry, cow parsnip, and then various native roses are going to be the natives that are present on this chart. And then the willows, which get their own classification, which are likely highly native. This is an interesting one because you can see just how pervasive that Himalayan blackberry is. It runs basically the entire creek with no break, and that's that green top one. And before I close out, I wanted to leave you with just some of the photos, just a small sample of the photos from the photo points that I set up to look at seasonal change in various areas of the creek. So these span early July to mid-September, and were really just a fun experiment in paying really close attention to those small changes over a season. I want to say thank you first and foremost to the U of O Center for Undergraduate Research and Engagement, or CURE, which funded this research. Thank you. And thank you also to Ignacio Lopez Busan, my faculty mentor. He's done a lot of great work on the creek and was a fantastic resource. And then I also just want to do a quick shout out for all of the software that helped me through this. So Mergent Maps was an excellent just app on my phone that I could use to really easily set these points and set up the features. And then Analyzing with QGIS, of course, and iNaturalist and PlantNet are great for identification. I'm currently working on my comprehensive project for my landscape architecture degree on the concrete channel in Amazon Creek, and I'm putting together a more in-depth report of this data, as well as an interactive GIS map to be available online with all of my ID points, hopefully. So stay tuned, and thank you for watching.